Number 9, kx minus 3y equals 4, 4x minus 5y equals 7. So we have a system of two linear equations in standard form, but I've got a constant in here, so I don't think we're solving for x or y. In the system of equations, k is a constant. For what value of k will the system have? No solution. So this is a solve for the constant problem. They're either going to be always true or never true. In this case, never true. So the way that's going to work is if my left side is exactly the same expression and they equal different numbers on my right side, then they can never, ever be true, right? Can't possibly have the same expressions equal different numbers on the right side. So how do I make the left sides the same? That's my challenge. Well, I've got minus 3y and minus 5y, so I'm going to multiply my left side by 5/3. So my minus 3 becomes a minus 5 when I multiply it out. Let's distribute it through. 5/3 times kx is 5/3 kx minus 5/3 times minus 3 is minus 5y to match the 5y below, and that equals 5/3 times 4, which is 20/3. Almost 7, not quite 7 though, okay? So what does that mean? I want to set 5/3 k, this coefficient of x, has to equal this coefficient of x4, just like the minus 5y's match, such that the left side is exactly the same for both equations. Okay, so that means 5/3 k equals 4. I'm setting the constants equal to each other. That is the coefficients of x in this case. Solve for k. K equals, multiplying by the reciprocal on both sides, 3/5, 3/5. K equals 12/5. And that's the answer that makes the left side expressions both 4x minus 5y, and one of them will equal 20/3, the other one equals 7, which can never be true. I can't have two different answers for the same expression. A is the correct answer for number 9. K equals 12/5. Number 10, the xy plane, the parabola with an equation y equals x minus 11 squared, intersects a line with equation y equals 25 at 2 points. Okay, so I've got a system of two equations. One is quadratic, one is linear. I can solve this a couple different ways. I'm going to start with a graphical approach. X minus 11 squared is a perfect square, and the minus 11 offset indicates that the vertex will sit at 11 on the x-axis, and that will go like that for an upward-facing parabola. It's going to intersect somewhere up here at 11 squared, which is 121 on my y-intercept, but I'm not so concerned about that. I want to know where it matches or crosses the line y equals 25. Well, how do I know I get up to 25? I get up to 25 if I go over 5 in either direction. That is 5 less means I go up 5 squared to 25. And if I go 5 to the right, that's to 16. Well, then I go up by x squared, which is 25. So the answer here is there's a difference between the 2 points. If I called them A and B, there's a difference or a distance of 10 between them. The correct answer for number 10 is going to be 10. All right, so that's one way to look at it graphically. The other approach is to solve the algebra. Let's solve by substitution. I've got y's in both cases, so 25, which is y, equals x minus 11 squared, which should also be 25, okay? So what might I do here? I'll take the square root of both sides, and I'll get x minus 11 equals plus or minus 5. The absolute value of x minus 11 equals 5, but x minus 11 will have a positive and a negative case solution. Okay, so solve for x. That's going to be x equals, add 11 to both sides, 11 plus or minus 5. That means x equals 16 in the plus case and x equals 6 in the minus case. Again, I want the length of AB, which is the difference between those two intersection points. So that's going to be 16 minus 6 equals 10. The correct answer, again, solving algebraically for number 10, is 10.